Hi everyone. So in this video we will be discussing your lab 2, which is covering the topic of density once again. And specifically this week you're using pennies immersed in water to explore the concept of density. So remember our density equation, mass over volume, and we will be once again graphing and using our data to determine density and think through some problems that are presented to you. So first we start off with this introduction. It just shows you how to measure the mass and the volume of the pennies. It goes through the setup. So this video below shows the setup that we'll be using for the activity. I will let you explore that. There's essentially two cameras that are within the video. One camera shows you the mass, the other camera shows you the volume. And they did a few extra special things so that you can see the pennies as they are dropped into the graduated cylinder. So one topic I would like to briefly discuss is how whenever you add pennies, or whenever you're adding any object, not just pennies, and I'm showing you the video just so there can be something on screen and to show you what I want to point it out once it happens. But whenever you add pennies in, you see how they're adding those pennies in? The volume went up. The volume going up is called displacement. So there's a word for that, the fact that the volume is going up. So you are going to be looking at how much the volume was displaced by, in other words, increased, how much it increased by. So that's an essential phenomena that's happening in this lab. So here's just a quick intro question, kind of testing your knowledge on the video itself. If you went through and watched it carefully, you will be able to answer this question about why some of the pennies are painted orange. Then we go through part 1. So in part 1, you will see the pennies being added into the graduated cylinder, and you're going to be responsible for either, what I recommend is you taking note of the mass and the volume after every time that pennies are added. So you can make a nice little table either on your notes that you have been keeping for this class or on Excel, for example. You can just keep something separate so that when it's time to answer the questions that I'm just about to scroll through, you will be prepared. So first, open-ended question, write down how you will determine the density of 20 pennies. So here's where you can use some of your context that you have learned in lecture and what you learned in lab 1, and you can explain that. And then here are where the measurements are asked for, and that's what I mentioned earlier, that it's nice if you record everything. That way when you're asked these questions, you have it, you're ready to go, and you can type it in. Now notice that it's leading up to this final question right here. Use your measurements to calculate density. So here is where you will use the information you just placed in the previous questions, and you'll actually use that to calculate the density. And then a final follow-up question. Now, this lab, for whatever reason, has a toggle button where you lock, answer, and continue. So you would click that, And then you'll notice that it goes on to part 3 and it skips part 2. And there's a reason for that. I had to remove part 2 because it called for a basically class assignment, and that was not part of what I meant to introduce in this lab. So just went ahead and took it out. That's a big FYI for anybody who was curious. There's nothing that you missed or anything. Just go straight to part 3. There's really no explanation besides that. So just go straight to part 3 after you lock that. You will be able to open up part 3, which is what I have opened here. So part 3. Here we start off with the part is called Will's Challenge. So what does this mean? And you start off with a question that makes you think. So this is basically testing your knowledge of the concept of density. And as always, I will let you explore that and come to your conclusion where you explain why or why not you agree with Will. Next, you have some data from a class of students. So we're going to use this and we're going to make a graph from this, okay? So the data's already there, which is good, right? You notice they have the number of pennies, the mass, the volume, and then the density, okay? Now, you can kind of just go ahead and move on just to see exactly what graph they're asking for. So another student makes a claim, and basically you should go to your graph and plot the number of pennies on the horizontal and the density on the vertical. Once you plot that, you can go ahead and examine it, make your conclusions from that, and then you can answer this question, okay? And the way you do that is the data is already input on the table. So all you have to do is for your horizontal, select the one that they told you and you press done. And then for your vertical, you select the one that they told you, you press done. It's going to generate a graph for you. Okay. Pretty simple. It's more about whether you really understand the concept of density and whether you can kind of make some arguments about that in a good way, right? Because you want to argue what is correct. So next up, there's part 4. And once again, you're going through a very similar process. You're going to repeat the process with a different batch of pennies. The density may not be the same because different pennies are made from different materials depending on the year. I'm pretty sure they used to be made of copper at one point. Not anymore. So that's why we're looking at a different batch. So use the same method and you're going to determine the density. What's funny, now that I mentioned copper, and sorry if I'm scrolling kind of fast, but you are actually going to figure out which batch. I don't know if it was the first batch that we looked at in part 1 or in this last part. You're going to determine which metal this last batch is made out of, and you'll get to compare it. So have fun with that and figure that out. Now, how are you actually going to do this? Like I said, very similar. You are going to watch the video. Now here you actually have a data table to fill in and help you record that data, right? So you don't have to worry about writing it down somewhere else. You have your handy dandy table that you can fill in. So I would suggest using the example from part 3 right here, generating a column of number of pennies, generating the mass column, and generating the volume column. Do I suggest the density column? You can at the very end, but what I would also suggest is not solely relying on this column, this calculation column, and I'm going to show you how this was calculated. They took the mass and they divided it. And I'm messing it up, but They took the mass, they divided it by the volume, and then they submitted, and that generated this column. It basically takes this actual value, divides it by this, generates this in this column. So why am I saying don't rely solely on this? Because we can actually use the mass and the volume to generate an average from all of these that we can visually see from the graph. So what do I mean by this? So you're gonna go ahead and generate the columns of number of pennies, mass, volume, density at the very end after you do the visual confirmation with your graph, with your graph. And then, okay, so you do that, you make your column of pennies, your mass, your volume. That's 3 so far. And then once you get your mass and volume in there, you're gonna come down to this graph. You're gonna configure your mass, right? Let's say, for example, this was my mass, or let's go ahead and fill it in. So you're gonna have number of pennies before this, but just for the sake of me, showing you here just how you should graph it, right? Oh, this should actually be the volume. So once you're done with that, you're gonna graph volume on your horizontal and mass on your vertical. This, once you have your beautiful data filled in, you will see that entering this graph will generate a beautiful line. And on that line, what you can do is add a curve fit. And you're going to add the curve fit to your mass, and you're going to click linear. That curve fit is going to generate this piece of information here where it gives you a y equals mx plus b. Yes, this is coming back to haunt you, but in a good way, because it's going to help you determine density. So how you get density is you look at the slope. So remember, slope is y over x, the change of y over the change of x, which is essentially mass over volume. What else is mass over volume? Density. D equals m over v. So you can get the density from this term right here, the slope, the a, and it's going to populate right there. And you're going to see that it says grams over ml if you enter that correctly into the table over here. And then at the end, you can generate the density column and see if it matches that density right there for term A. And then you can describe how you found it. Very simple. And then, you get your density from here, A, and also from the table once you generate it with the change formula column. And you confirm, okay, they match, that's good. And then you come here to this table and you say, okay, my density, the value of it matches XYZ the most, right? I'm not going to say anything because I don't want to sway anybody toward any metal, but you're going to pick the one that is closest to your density value and you are going to enter it here. And that's the end of this lab. So I think that covers about everything. If you do have any questions beyond what I discussed here, please let me know and I will follow up with an answer. Thank you for watching, and again, let me know if you have any questions.